Hello, 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 ladies and gentlemen. Root Beer here, and we're on the penultimate question, the second to last question, question number 9 on the 2007 Euclid contest. Okay? If you haven't given it a look, I do encourage you to stop the video, download a copy of the contest, or even just wait a second when I show the question and pause the video. Try it for yourself. That really is the best way to learn. Practice makes perfect. But let's get into it. Question number 9. So, the parabola y equals f of x equals x squared plus bx plus c has vertex p, and the parabola y is, and we're calling it g of x now, equals negative x squared plus dx plus e has vertex q, where p and q are distinct points. Okay. The two parabolas also intersect at p and q. Ooh, extra information. Prove that 2 times e minus c is b times d. And these are the values that we've got in the expressions for the parabolas. Okay. And then we've got something else to do. B, prove that the line through p and q has slope 1/2 b plus d and y-intercept 1/2 c plus e. Very interesting question. Okay. Now, they say they say that p and q are vertices. Well, let's transform these parabolas from standard form equations into vertex form equations. Now, I know we don't have the actual coefficients b's and c's here, but we could still get the vertices, their coordinates, from putting these in vertex form, even if we have to keep all these coefficients unknown. And they will stay unknown for the whole thing, because we're proving sort of a general result. So we'll put this in standard form. Not that. So what can we do? Well, we can change it to x squared plus bx plus b over 2 all squared minus b over 2 all squared plus c. And then that becomes x plus b over 2 squared plus c minus b squared over 4. Let's say that. Yeah. Okay, so this is now in vertex form. So p has coordinates negative b over 2, c minus b squared over 4. Alright, so the other one, x squared plus dx plus e. Now this minus sign needs to come out, so we'll change it to x squared minus dx minus e. And now minus x squared minus dx plus d squared over 4, same sort of thing, minus d squared over 4 minus e. And minus x squared minus dx plus d squared over 4. Now the minuses come out, d squared over 4 plus e. And this is negative x minus d over 2 squared plus d squared over 4 plus e. So q has coordinates d over 2 d squared over 4 plus e. Alright. So now I better understand p and q. Now, in the question, I think they also said that the parabolas intersect at p and q as well, which is quite interesting. And that means that p satisfies this second equation, and q satisfies the first equation as well. Prove that the line through p and q has slope 1/2 b plus d. Well, I think that wouldn't be that hard to show, because now I know what p and q are. We also know the y-intercept as well. So let's see if we can do b before we can do a. Maybe we can, maybe we can't. I don't know. But the slope of PQ, it's going to be rise over run. So I'm going to have to flip back for a second. So rise, that's the difference in the y-coordinates. So that'll be c minus b squared over 4 minus e minus d squared over 4. All over the difference in their x-coordinates, and that'll be negative b over 2 minus d over 2. Okay, now I'm not liking this because I've got the c's and the e's, but look at what they want me to show. They want it to be 1/2 d plus b plus d, and I have a feeling that this expression, so actually I think solving a will help things. So I guess we better solve a first. Okay, we'll come back to this later. But how might we do a? So we know p is on negative x squared plus dx plus e, and q is on x squared plus bx plus c. Okay. So, well, we know the x-coordinate for p, and we know its y-coordinate, so that tells me that negative b over 2 squared plus d negative b over 2 plus e is equal to c minus b squared over 4. Okay. Correct? Yep, c minus b squared over 4. So plug in the x value, you get the y value out. And we can do the same thing down here with our d over 2 and our d squared over 4 plus e. So we know that d over 2 squared plus b d over 2 plus c is equal to d squared over 4 plus e. Okay. So, I'm going to leave a little bit of... No, we won't leave a bit of space, but we will rewrite that first equation. Negative b squared over 4 minus bd over 2. Now, the expression we wanted had a bd in it. Plus e equals c minus b squared over 4. Well, hey, the b squareds cancel out. The minus b squareds over 4. And then we're left with... we'll bring the c over to this side and the bd over 2 onto the other side. And now we get 2 e minus c is bd. And that, if I'm not mistaken, is what they asked for in part A. It absolutely is. Okay. So now I think we can use this to prove B part. So now the slope of PQ, and it was rise over run okie dokie. I'm going to multiply top and bottom by 4, I guess. And I'm going to group the c and the e together. So minus b squared minus d squared. And then we'll have negative 2b plus d here. And I guess I can make this b squared plus d squared there. Okay. Okay. Now this c minus e, well, I know that 2e minus c is bd. So if I multiply that by negative 2, I'll get 4c minus e is negative 2bd. So now I've got negative 2bd minus b squared plus d squared over negative 2b plus d. Well, actually, I can now, I guess I can divide by -2 on both sides, or on the top and the bottom. So we'll get b squared plus 2bd plus d squared is all over 2b plus d. But that top part is just b plus d all squared. So we're left with b plus d over 2. And that's exactly what they wanted us to show with the slope. And now using the slope, I suspect that we can get the last thing they wanted, which was the y-intercept. Okay, now, P is on the line PQ, which has slope. By the way, if you were having trouble getting the slope and thought you could get the y-intercept, you could absolutely use this statement, say, I'm just going to assume this is true and get the y-intercept. That's certainly something to do. You would more say, well, gee, I'm stuck on A, but I'll assume it's true and I can do B part. And that's something that's okay to do. I mean, it's not great because you should be trying to get all the marks. But, you know, if you need to assume that A is true to solve B part, that's fine. In general, you won't ever have to do that because A part should be easier than B part. But it's a viable strategy. Just because you're stuck on part A doesn't mean you can't try part B. Anyway, so we've got slope B plus D over 2. So I'll let Z be the y-intercept. And then I know y equals b plus d over 2x plus z. But we have c minus b squared over 4 is b plus d over 2 negative b over 2 plus z. And we get c minus b squared over 4 negative b squared over 4 minus bd over 4 plus z. Once again, the negative b squareds over 4 will cancel out. And I will bring the bd over 4 over to the other side. So I have an expression for z, but it's not quite the expression that they're looking for. They're looking for a half c plus e. But we have a bd here, and we know from a part that we can rewrite bd as 2e minus c over 2. Or sorry, 2e minus c, and then it's still over 4 here. Right? It was 2e minus c. Yep. Okay. So I'll just draw in arrows to direct people. So z is c plus 1/2 e minus 1/2 c. Just simplifying our fraction here. But c minus 1/2 c is just 1/2 c. So we have 1/2 e plus 1/2 c, or 1/2 e plus c. And that is the last thing we needed to show. So that was actually a very straightforward question number 9. They gave us all the information we needed. You know, vertices P and Q, so vertex form, very natural. They intersect at P and Q. That just means that Q is on P's parabola and P is on Q's parabola, and that very naturally led into A, and from there we got B. So that was actually a really nice question. I liked that one a lot. Hoping 10 is just as good. And in the next video, we're going to check that out. We're going to see if 10 really is that good. So join me for the last question on the 2007 Euclid contest in the next video. Until then, have a wonderful day.